Okay, so today we are going to learn about the quadratic formula, which is a method to solving quadratic equations when we can't factor them. Remember that it's a quadratic equation because our highest exponent is 2. So we have our highest exponent here is 2. We have if ax squared plus bx plus c equals 0, then the solutions, or roots, or x-intercepts, which are another name for solutions, are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So all we are doing is replacing our a with our a here in the equation, our b with our b, and lastly our c term with our c. Now there is a fun song that you can sing to the quadratic formula, but you don't want to hear me sing, so maybe Miss Allison or Mr. Wren will sing for us tomorrow morning in class. First example, use the quadratic formula to find the x-intercepts of x squared equals negative 6x minus 36 equals 0. Sorry, I said that wrong. X squared minus 16x minus 36 equals 0. So remember, our equation is ax squared plus bx plus c equals 0. So our a term is whatever our coefficient is for x squared. We don't have a coefficient there, so that means it's going to be 1. Our b term is our coefficient for the x term, so that's negative 16. And our c term is the constant that's by itself, so that's negative 36. So when we plug into our formula, we're going to replace all of our a's, b's, and c's. So I have x equals negative, our b is negative 16. Whenever you plug negatives in, it's always good to have parentheses, plus or minus. That's just a symbol that means that we're going to add and subtract the square root of negative 16 squared for my b. Again, I plugged that in parentheses, minus 4 times my a term, which is 1, times my c term, which is negative 36, all over 2a, which is 2 times 1. Alright, now we're going to simplify this. So negative 16, that's going to turn into a positive. So I'm going to have x equals 16. Let's stick with black there for a second. 16 plus or minus the square root. 16 squared is 256, and you don't need a graphing calculator for that. You can do that on a computer calculator. And then negative 4 times 1 times 36, times negative 36 turns into a positive 144. Divided by 2 times 1 is 2. Alright, we're going to simplify now what's underneath the radical. So I have 16 plus or minus 256 plus 144 is the square root of 400 divided by 2. Alright, now we need to see if there's a perfect square in 400. So using your calculator, put the square root of 400. If it's a whole number, we'll write it down. If not, we'll leave it as it is. Square root of 400 is 20, so we're going to write that down, divided by 2. And now we're going to have two answers. So we're going to have x equals 16 plus 20 divided by 2, and x equals 16 minus 20 divided by 2. So 16 plus 20 is 36 divided by 2, which is 18. 16 minus 20 is negative 4 divided by 2, which is negative 2. So our two solutions are 18 and negative 2. Alright, next problem. We have, this is a try this. So try this. Use the quadratic formula to find the x-intercepts of x squared minus 7x plus 6 equals 0. Did you get 6 and 1? If not, make sure that you ask questions tomorrow as we go over this problem. Alright. Next example. Example 2. Use the quadratic formula to find the x-intercepts of 5x squared minus 7x plus 1. So remember now, our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now our a is 5, our b is negative 7, and our c is 1. So I'm going to have x equals negative, my b term is negative again, so make sure you put parentheses around that. That won't always be negative. Plus or minus the square root of b is negative 7 squared minus 4. My a term is 5, and my c term is 1. So negative 4 times 5 times c. All over 2 times a, which is 2 times 5. Alright, let's simplify what we can. Negative 7 turns into a positive 7, plus or minus the square root. Negative 7 squared, plug that into your calculator, you get 49. Negative 4 times 5 times 1 is negative 20. All over 2 times 5 is 10. Alright, let's keep simplifying underneath our square root, and we get 49 minus 20, which is the square root of 29, all over 10. Now, we want to check to see if the square root of 29 is a perfect square. So plug that into your calculator, and you end up getting a decimal. So that means that we can't simplify this anymore, and our final answer is x equals 7 plus or minus square root of 20 divided by 10. Okay, one more problem. Try this. Use the quadratic formula to find the x-intercepts of 2x squared minus 6x plus 3. Did you end up getting 6 plus or minus the square root of 12 over 4? If not, make sure you ask questions when we go over it in class tomorrow. Now, if you've listened all the way through, please draw a star on the bottom right-hand corner of your note sheet. And do not tell anyone, because there will be a prize for you if you do that.